Oh yeah. How about a worked example in 1D? This is going to seem a little bit silly at first. I just want you to trust me that sometimes it's worth it to do an overly simplistic problem with the right notation to learn something. Give me just a second here. So the idea, I bet you could look at this problem in your mind and say, oh, clearly B is moving at 5 meters per second relative to A. All right. And you could probably even figure out that B is moving this way. But if we're going to try and do this with complicated 2D and 3D vectors, why don't we at least see how it looks in 1D in the correct vector notation? And we know the answer should be 5 here, right? And then to the left. But that said, let's go ahead and work this out. Well, remember, we want to use, in this case, I'm looking for VB relative to A. And if you're working along in the workbook, this is problem 4.26 on page 78 in volume 1. All right. Well, okay, so pause the video if you need to look that up. It's essentially doing this problem. But in this case, and maybe what I'll do is I'll give you a visual on it really quick. Whoops, that's not what I want to do. I want to do, whoops, this one. Sorry about that. So from the Earth's perspective, this is what it looks like. One of them's moving backwards at 3, one of them's moving at 2. We can see the blue one's moving a little bit faster there. And from B's perspective, this is what we want to figure out. This is what it looks like from B's perspective. And this is what it looks like from A's perspective. We can see that essentially the objects are moving at 5 meters per second relative to each other in different directions. All right, then let's stop that. Okay, and let's stop that. And then we go back to here. All right, so we want to make our vector math look right and get the answer 5. How do I do that? I'm showing you here. I want to do these two. B comes first, so I'm going to grab the blue marker and I'm going to say the velocity of B relative to the Earth. And then I'm going to come over here and I want to use A. Notice A comes second, so it's second in the addition, but I also need A to be the second subscript. So I don't want VAE. This would be wrong. This is not right. No, bad. I need to do VEA. Look at this. B is the first term. I use B Earth. A is the second term. I use Earth A. And this is how I remember it, even though it seems a little bit silly here. E is the variable that gets squeezed out in the middle, and I'm left with just VBA on this side. If you recall from the last video, I can get this information because VAE is equal to the opposite of VEA. You might be saying, why don't you just remember this the other way with a minus sign? I don't know. This is just how I grew up and how it works for me. So I hope this works for you. I find it, I don't know, it just works better when I have the plus signs here and then only added minus signs if I need them. More on that as the examples change. You'll see. I think of this as a velocity addition problem now, right? Because I think of this as add up the velocities, and that's okay, enough said. Well, in this case, what is this thing up here? It's 2 meters per second relative to the Earth for A. So I would say VAE equals 2.00 meters per second. In this case, what direction? We're going to call that I hat. So we're assuming here a normal coordinate system where this is the positive X direction and this is the positive Y direction in this problem. All right, well, if I use this result over here, that tells me that VEA is negative 2.00 meters per second I hat. Okay, I know this seems like overkill, just trust me. Okay, when we do the next problem, all we have to do is add in the J hats and you'll be good. Okay, look at this case. In this one, what's VBE? Well, VBE is 3 meters per second to the left, negative 3.00 meters per second I hat. Got it. At this point, I can stick these two numbers in here and I should be able to get the correct result. So I see, in this case, VBA is equal to, VBE is that number. Then I'm going to add to it, not VAE. I got to use this to squeeze out that E. So I get a. And other people might do this other ways, but I am getting the right answer. All right, so we're saying that the motion of B relative to A is negative 5.00 meters per second. So think, when I was doing the simulation, is this having the drone follow B or follow A? Pause the video if you care. It's having the drone follow A. Okay, so in this case, if I'm in a drone and these are two people, one's walking to the right, one's walking to the left, I want the velocity of B relative to A. So imagine the drone just locks itself here above object A and keeps drifting to the right. Well, then this thing's going to have to be going faster than 3 relative to the drone, which is locked onto A. It's going to be going at 5 to the left. So showing you this one more time, and that's the whole problem. That's it. Not too bad, right? Let's go back there and look at this. So in this case, if I want to see this, I want to see everything relative to A. I'm going to hit the A button. A is at rest relative to A. The planet Earth is moving to the left at 2 meters per second relative to A. And object B is moving to the left at 5 meters per second relative to A. That's it. Nothing too crazy. Not too bad. All we got to do to make this harder is add in more than one dimension, right? If you had I hat and J hat, suddenly it gets a little bit trickier, but the process is exactly the same. It's straight up velocity addition, vector addition. Okay,